So let's take a look at some ways to just summarize a whole bunch of adding and multiplying for various relation classes. And I'm just going to look at the example of Z4. So let's take a look at what happens if I add all of these classes. This is going to be really, really nice to be able to recognize patterns off of this. And again, I mentioned it many times before, this is going to be something that you're going to be doing a lot of, or at least similar to, in modern algebra next spring. So if I add these two, if I add 0 plus 0, I'm going to get 0. So what I'm going to do is I'm going to look at all these possibilities and what happens if I add numbers here to numbers here. So you can just fill this out on your own and just fast forward the video to see at the end if you have the correct answers, or just listen to me just kind of work through all of this. So you add 0 plus 1, you get 1. Add 0 plus 2, you get 2. Add 0 plus 3, you get 3. Nothing really special happens there. I add 1 to each of these. I add 1 to 0. I add 1 to 1. And I get 2. I add 1 to 2 to get 3. I add 1 to 3 to get 4. But remember, we're not really working with the relation class of 4. We're going to simplify that to 0. I now have... this one's going to be 2, 3, 0, 1, and this one's going to be 3, 0, 1, 2. So notice we just have basically shifted all of these over, and that makes sense, right? That you just take 0, 1, 2, 3, and then you're just going to shift everything over. So you're going to bring the 1 over here, the 2, the 3, and then the 0 loops over there, and then you just kind of go, again, one more shift and one more shift. Now multiplying, we do the same thing. I take 0 times 0 to 0 times 1, 0 times 2, and everything. So what I get is this becomes a row of zeros. Right? 0 times all of those entries just becomes 0. I take 1 times all of these entries, and I'm going to get the same thing. 0, 1, 2, 3. If I now multiply 2 by any of these, I'm going to get 0. I'm going to get 2. Now, if I take 2 times 2, I get 4. But again, that's 4 is going to be the same thing as 0 mod 4. And then if I multiply 2 times 3, I get 6. And that's the same thing as 2. And I do 3 times this, I get 0. I get 3. 3 times 2 gives me 6. And that's the same thing as 2. And then I have now 3 times 3, that gives me 9, which has a remainder of 1. So notice when we were solving equations back in the couple of videos ago, when we looked at multiplication, we looked at it, say, modulo 5, and we looked at it modulo 6, and we were able to solve some things, and sometimes we weren't. Here is a perfect example that now we could see some of the types of solutions that if we were to solve, say, 2 times x equals 2, I'm going to get 2 different solutions, right? 2 times 1 gives me 2. 2 times 3 gives me 2 as well. Also, 2 times 0 and 2 times 2 both give me 0. But if I was to, for instance, solve 3x is equivalent to 1 mod 4, well, what do I multiply 3 by to get 1? Well, the only thing that works is 3. So I would see x is equivalent to 3 mod 4. So when you create this table, you can now see when are you possibly going to get repeated answers, and when are you always going to be able to solve something, right? Obviously, if it's 0 times x is equal to some 0 mod 4, you get a whole bunch of answers. If it's anything else, you get no solutions. So you have this, hopefully, a nice visualization now of seeing the types of patterns that will emerge of repeated ones versus distinct ones.